Hi, good evening, one and all. So today I would like to explain about the clustering of my data set. So, um, so first of all, as usual, I have import all my libraries, and I use my data set, which is a raw data set, my about my top 2018 um, data set. So after as usual, we used to verify the data set, and after that, so in this section I would like to do a mean normalization. So here in this section I would like to make a mean normalization. Here I used to take for that all my attributes. Here I have taken all my attributes, and then I used to do a mean normalization with standard scalar. For that I import all my libraries from sklearn. Here I calculated my fit, and I apply the transformation. So here you can see that about my scale data, and I used the index and column arguments to keep my original indices and columns and names. Here you can find my top norm as well. So later here I just build a simpler scatter plot, which is I have taken two x-axis and y-axis. See here you can see my x-axis is key and top on norm mode, which is x label is normalized key and y label is a normalized mode. And you see here you can find my key and node, which is x-axis and y-axis of my plot of data. After then, so we all know that elbow method, which is also a simpler and popular method, which is used to group a similar data topics together and discover underlying patterns, and so to achieve a k-means, and also next that k-means and booking data set. So here on the clustering with k-means node, like variable labels is an array. Here you can see the I have taken like clusters 3, which specifies the clusters of each dog belongs to, and imported my k-means. See here you can find my array of list of array, which is data type is integer, and here you can find so I'm now initializing the row counter. We are now going to through each row in booking data and appending the cluster labels for a number of each indexes. So here from index row in top num rows, so here you can find my index of I, which is label, and appending the index I plus 1. So here you can find a pretty list items. So here about my the cluster and the value name of the dogs as well. Here you can find all my this one. So later I have assigned the cluster labels that k-means has assigned to y labels. Here x-axis is like top 1 array and y is the labels. Here you can see here read the local labels have colors matching with this. So here, so in this data set, like I have taken ax dot set x label as key is my attribute, and anything attribute we can take, like out of 13, and y label I have taken mode, and z label I have taken loudness, or set label which is k3, and you can see the k-means output, which is k is equal to 3, which is k and mode x-axis and y-axis. After that, so I have done that how much the k is big as, like now we plot the output for our k-means analysis for k is equal to 3 and 8. So for suppose clusters 3, 8 clusters and 3 clusters I have taken. So here you can find, so I have taken a fixed size, which is 4 and 3. Anything we can take, like 3, 5, 4, 5, 7 or anything. I have taken 4 and 3 here, and size elevator 48 size or anything, and I have taken x-axis site room count, image count, and I have taken the this one elbow method. So here you can find all my parameters and also everything you can and I have written the plow show. Here you can find my graph here about mine. So coming to the next question, hierarchical clustering. So normally we specify these like how much clusters to make, at each. So it combines the two most similar clusters into one. This is called normally a hierarchical clustering, and it names make sense. So first thing we need to import here cluster input from algorithmic clustering. After that, see, you can find the cluster. I have the linkage and the labels. I got an output of arrays of zeros and ones. So for that, next one, hierarchical clustering and endograms. I have imported all my libraries here. I have taken left to right, and then which is indexes. You can find all my indexes here. So later I have import plotty sff, and I'll show my updated layout here. I have taken width 700 and height 600. So here, this is my graph, which is 700 and 600 width here. You can also plot with pandas. Also later, see here, this is my graph. And for the density based, normally a density based clustering finds core samples of high density and expands its clusters. It views the clusters as areas of high density separated by areas of low density, high density by low density. So normally I imported all my from cluster from dbscan and metrics. So I imported the data from sklearn datasets make mons, and mode 1 EPS is the radius, which defines the neighborhood for a data point. And dbscan model requires, normally it requires two parameters, EPS and minimum samples. Minimum samples is the minimum number of points required to form a dense region with a radius EPS. So here, and also there is another way to get the parameters and definition of the dbscan mode 1. Here you can find these one. Later I'm reviewing the labels. We cannot take a look at the cluster labels that our model 1 has assigned. Here you can see the label 1 equal to mode 1 dot label. Here I got the arrays of -1. So, and also there is an alternative way to access the cluster labels. You can like dot fit predict using the method predictx. So I got the array and also the plotting the clusters. I have taken the so size anything 140, even we can change here like to 150 or anything. So labels. So, and also a number of clusters in labels. Here you can find the I have printed all my estimated number of clusters, which is in percent if there is noise in the dataset. We also identify the noise points, like we can print here. You can find the noise points like using the sum of length of model labels and evaluating the model completeness and homogeneity scores. Like a clustering result satisfies the homogeneity if suppose all of the clusters contains only a data points which are members of a single class, or clustering results also satisfies the completeness if all the data points that are members of a given class and elements of the same cluster. So here you can see that I have printed my completeness of the 0% if metric completeness scores of arrays of 0 and 1, and also completeness of given classes placed into a cluster even. And also I have done my homogeneity for a given cluster as well. You can find homogeneity 0.0. So this is all my data set about. So thank you so much one and all. Have a good day.